In this video, we'll take a look at applications of vectors from section 9.4. We'll take a look at two instances where we have forces at right angles, and then if we have forces that are not at right angles. So remember from the last section that if you have forces at right angles, if r sub x and r sub y are the components of the resultant vector, that means the x and y components of your resultant, then the magnitude is equal to the square root of r sub x squared plus r sub y squared, and the reference angle is equal to the inverse tangent of your r sub y divided by r sub x, the absolute values. So our first example is from the book. In centering a figurine on a table, two persons apply forces on it. These forces are at right angles and have magnitudes of 6 newtons and 8 newtons. The angle between their lines of action is 90 degrees. What is the resultant of these forces on the figurine? So if we take a look and think of it as setting the two forces at 90-degree angles with the x-axis and the y-axis, then we have 6 newtons this direction, and we have 8 newtons this direction. You could go the other way as well. Then the resultant is going to be the diagonal of that parallelogram, or in this case of the rectangle. So the two things we're looking for are the length, which is the magnitude, and we're looking for the angle that it makes with the 6 Newton force. So our force F of x equals 6. That means your x-coordinate here is 6, and your y-coordinate is 8. Since it's at right angles, those are already basically given to us. So to find the length of our vector f, or our magnitude, we take the square root of 6 squared plus 8 squared, and we end up with 10. So the length of this is 10 newtons. So that's the resultant. Now we want to find that angle. So again, think about this as a right triangle of two sides, 6 and 8. It could just as easily have drawn a right triangle here. And the inverse tangent is going to equal our y-coordinate over our x-coordinate. So we have the inverse tangent of 8 over 6, which is 53.1 degrees. So this angle is 53.1 degrees. So now we found the magnitude and the direction. So the resultant has a magnitude of 10 newtons and the direction of 53.1 degrees from the 600 Newton force. So we're going to try that with an example from your homework. In testing the behavior of a tire on ice, a force of 480 pounds is exerted to the side, and a force of 700 pounds is exerted to the front. So think about these as being at right angles to each other. So you have a force of 480 and a force of 700. And what we want to find is the resultant. So the resultant is going to be the diagonal of that rectangle. So you can think of this in a couple of different ways. You can think of this as a right triangle where we know two sides, and we can find the length of the third side. So the magnitude of the resultant force is going to equal the square root of 700 squared plus 480 squared. We're going to throw that in the calculator, and I've done that a little bit earlier. So what we end up with is 848.76. It says, let's see, round to the nearest 10 is needed. So rounded to the nearest 10 would be 850 pounds. Now we want to find the angle the resultant force makes with the force on the side of the tire. Okay, so 700 pounds is exerted on the front, 480 is on the side. So actually what we're looking for is this angle right here with the side. Okay. So we'll just keep that in mind. So we're going to find this angle and keep in mind that we need the angle with the side of the tire. So we're going to look at the inverse tangent, our reference angle. is the inverse tangent of our y-coordinate, which is 480 over 700. So let me bring up the calculator. Make sure that your calculator is in degrees. So mode, yep, it's in degrees. So I want inverse tangent of 480 divided by 700. And I end up with 34.4 degrees. Well, that gives me this angle here. That's the angle from the front, not the side. We want the angle for the side. So we're going to have to take 90 degrees minus 34.4, and we end up with 55.6 degrees. So this angle is 55.6 degrees. And it says round to the nearest integer is needed, so that rounds up to 56 degrees. All right, next example. We're looking at ship displacement. So this one gives us direction according to bearings, north of east. So a ship sails 32.5 miles due east. So take a look at the picture. We have an XY coordinate system set up with east, north, west is over here, and south. So if we're sailing 32.5 miles due east, then we're going right along the x-axis. And then turns 41.25 degrees north of east. So from here, we're turning 41.25 degrees north of east, and then traveling another 16.18 miles. Then after sailing at that 16.18 miles, where is it with reference to the starting point? So we want to find where displacement means how far have you traveled from where you started. So we want to find this resultant vector, and then we also want to find the angle it makes with the x-axis. So we're not given the components this time like we were last time because they were at right angles. So we have to find the x and y components of our two vectors. You can also think of this vector b as being over here. And then we're looking for the diagonal. Okay? So remember, when we add two vectors together, we're going to add together vectors a and b to get our resultant vector before we can do much of anything else. So vector a, remember that the components, the x components, are a times the cosine theta, y components are a times the sine theta. So our x and y components of a right here, your x and y, x component is 32.5 times the cosine of 0. The cosine of 0 is 1. So actually, the xy components, since it's on the x-axis, is 32.50. But if you put it in the formula, you get the same thing. 32.5 times the cosine of 0 is 32.5. 32.5 times the sine of 0 is 0. So those are my components for vector A. Vector B, xy components, are going to be here. So the x component is 16.18 times the cosine of 41.25 degrees, and the y component is 16.18 times the sine of 41.25 degrees. So now we know the two vectors, we can add them together to get the resultant. So this is the procedure from section 9.3. Add the x components to obtain the x component of our resultant, which is 44.66. Add the y components to obtain our resultant vector. So we add the y components, we get 10.67. Once we have those, we can substitute them into the magnitude formula. So the magnitude is our x components squared plus our y component squared, which is 45.92 miles. So that represents the length of our resultant vector, 45.92 miles, and that represents how far we are from the starting place. Then we use inverse tangent to get the angle. The reference angle is the inverse tangent of your y component divided by your x component. And throw it in the calculator, you get 13.44 degrees. So the ship is 44.66, let's see, nope, the ship is 45.92 miles from the starting point in a direction of 13.44 degrees north of east. So notice we have to say the degrees here, north of east. All right, so the example from your homework. An airplane has an airspeed of 580 kilometers per hour, bearing 46 degrees north of east. So I've drawn airplane vector A, 46 degrees north of east. So draw your north, south, east, west. So that vector is 580 kilometers per hour. So that vector is 580 magnitude. Okay. Then the wind velocity is 80 kilometers per hour in the direction 35 degrees north of west. So draw your separate wind vector 35 degrees north of west. So that means you start on the west and draw 35 degrees north. So this vector has a magnitude of 80 kilometers per hour. So what we're looking for if we make the parallelogram is we're looking for the pink vector. We want to know how long that vector is, the magnitude, and then we also want to know what angle it makes with the east. So we're going to follow the directions from above. First of all, we have to find the components of vector A and the components of vector B, and then add them together to get the components of vector R. So to find your components of vector A, that's the airplane vector, AX is going to equal the length of the vector, 580, times the cosine of the angle, 46 degrees. Then we end up with 402.9. The y component is going to be 580 times the sine of 46 degrees. And that ends up being 417.22. Now we're going to find b sub x and b sub y. The x component of the wind vector is 80 times the cosine. Now, this gets a little tricky because it's not the cosine of 35 degrees. Remember, the angles are made in standard position, starting with the x-axis. So you have to use the angle from the x-axis. So if that's 35 degrees, then the angle it makes from standard position is 100 minus 35, which is 145 degrees. So that's 80 times the cosine of 145 degrees. So our x component is equal to negative 65.53. And that makes sense. It's negative because it's in the second quadrant. Then the y component of vector b is 80 times the sine of 145 degrees. And that would be 45.89. So now that I've found the components, the x and y coordinates for vector A and vector B, I add those together to get the components of the vector I'm looking for. So the x component of my vector R is going to be 402.9 plus a negative 65.53, which equals 337.37. Then add together the y components. We get our vector a sub y, which is 417.22. Add together the y component of vector b, which is a positive 45.89. Oops, 89. And that equals 463.11. So we found the x and y coordinates of our vector. So up here, what we found are the x and y coordinates And since we know the x and y coordinates, now we can think of this as a big right triangle and find the magnitude. So the magnitude is going to be the square root of our x coordinate squared, which is 337.37, plus our 463.33, 0.11. The x and y coordinates are both positive, which makes sense if you look at our picture. Our resultant vector is in the first quadrant. So when we throw that in the calculator, we end up with 572.97. And we want to round that to the nearest tenth as needed. So that's going to be 572. That's going to round up to 573 to the nearest tenth. So the aircraft is moving at a speed, the ground speed is 573 kilometers per hour. Okay, now we can find the direction. So the direction of our reference angle, in this case it's in the first quadrant. It's the inverse tangent of our y coordinate, 463.11, divided by our x coordinate, 337.37. Put that in the calculator, we end up with an angle of 53.93 north of east. So we want to the nearest tenth, so that's going to be 53.9 degrees north of east. So this angle right here, 53.9 degrees north of east. So if you can try to keep it straight and think about the right triangle trigonometry that we did, and that the vector components are really just the x and y coordinates of where the terminal side is that make right angles with the x-axis, right triangles. It's all about right triangles.